Hello, welcome everyone to tonight's class on Spe Hysys. So I believe you all can hear me. So if you can hear me, I would like you to um, drop a message on the chat box. If you can hear me, please drop a message on the chat box. Yeah, I would like you to introduce yourself. Um, are you a member of SPE? Are you a graduate student? So basic introduction. So please, if you can hear me and you can see my screen, I would like you to please indicate in the comment section. Okay. Erickson said that he can hear me. Dauda also can hear me. Okay. Welcome, welcome, welcome. I would like you to, introduce yourself. Where are you joining us from? Which part of Nigeria? And also, if you are outside Nigeria, participating into this class. Wow. Okay. Nice meeting you, Francis, rather, graduate SPE member. You're welcome. So I am Francis, but the person's name I'm saying here is IJ. IJ Franny. Okay. Anyways, nice meeting you, Francis. So I'm still waiting for more persons to participate, introduce yourself. So secondly, I would also like to know if you have used Aspen Hysys before, or rate yourself. Are you beginners, intermediate, or advanced? But I know that there are some professionals that are also joining this session. So I would like to know you uh, if you're a professional, you are a beginner, or you have intermediate knowledge. If you also haven't used Aspen Hysys before, I would also like you to indicate, so that I know how I will break down the class. If I know that more persons are beginners, I'm going to take it in beginners level. But if I know that there are more advanced persons here, I don't need to start teaching them beginners stuff. So yeah, those of you just joining, I would also like you to introduce yourself. Are you a student, a graduate, you're working? Okay, we have more of beginners in training. Wow, that's good. Okay. Wow. Okay. We have someone from Cameroon. Sixtus. Wow. Nice meeting you, Sixtus. Um, you said you're a student. What course are you studying? Chemical engineering, petroleum, gas engineering. What course exactly are you studying? So for those of you that are chemical engineering inclined, or you studied chemical engineering, please indicate, be it undergraduate or graduate. Then those in petroleum also indicate. So represent the department or your course of specialization in the chat box. Okay, fresh graduate chemical engineering is Erickson. Petroleum engineering. Okay, petroleum engineering again. We have two petroleum engineering, one chemical engineering. Our friend from Cameroon is in petroleum engineering. We have one gas engineering. Okay. Please, I would like the engagement in the comment section to go on. So while we do that, I'm going to introduce myself and the brand I represent. So my name is Prince Christopher, and I'll be your instructor for today. I'm a simulation engineer and also an instructor using Spe Hysys. And I've been using Spe Hysys for the past 4 years in the oil and gas sector. I've also been training actively in this for the past 3 years. Okay, and this training is brought to you by Ria Grand Engineering Trainings, and the acronym is RENT. So RENT is a training is a training organization, and basically what we do. We know that there is a gap between there's this gap between the academia and the industry. So as a training institute, we bridge that gap, and doing what we are doing now is one of the ways we do that by running comprehensive training for fresh graduates and undergraduates, those that want to boost their portfolio. We do basically manpower development, capacity development, training in the oil and gas sector. We train on AutoCAD. We train on AutoCAD 3D, AutoCAD Civil 3D, Aspen Hysys, Aspen Plus, Fusion 360, process engineering design, piping engineering design, instrumentation. We train on auger and pipe sim. So most of the trainings you need to excel in the oil and gas. Ria Grand is the #1 training institutions you need to go for. So we also partner with organizations for graduate training programs, and we also run campus programs and corporate programs. So for companies that want to organize trainings for their staffs, we also handle such trainings. Our training is broken down into different categories. We have physical trainings, we have virtual trainings, just like the one you are participating in. We also have corporate trainings and private trainings. So private training is specific for those in Port Harcourt, because that's where our head office is. If you want someone to come train you in your home or your office, be it physically or virtually, we handle those kind of trainings. So before we go into the topic of today, I just run some kind of survey, and I noticed that a lot of you here haven't used Hysys before, but this is one software that is important. It's very, very important, be it in petroleum engineering, gas engineering, chemical engineering. This software is key. So why is it that one spent 5 years in school but can't learn this software that's not going to take him more than a month? That's because most of our academic calendar are not well equipped to build you and make you ready for the industry. So when you get there, that's why before you get into the industry, you always go through graduate training program. And the essence of that is so that you can learn those things that you're supposed to learn in the university, which you didn't learn. And not everyone has the opportunity to enroll for a graduate training program. And sometimes for you to scale through, you need some skill sets. These skill sets are important. So for instance, you're an engineer, you don't know how to use AutoCAD. It's at least that's the basic thing every engineer needs to know how to use AutoCAD. First of all, that's basic stuff. Then you can move graduates to Excel. Now, I'm saying this due to the financial cost. Learning Excel isn't difficult because when you are into the industry, most of the things you are going to be working on, be it progress reports, Excel is one of the things you are going to be doing, report sheets, data sheets. Those things are being done with Excel. Then, based on your discipline, Aspen Hysys is one key area, one key software you need to learn. So as we go on, I would like you to this live session so that more participants can also get information about this session. This is free, so what we just want you to is like and share these trainings to other persons that you feel it will be of benefit to them. Excuse me. Okay, so I give those two softwares based on cost implication. So learning Excel to beginners to advanced isn't expensive. AutoCAD isn't that expensive compared to Aspen Hysys. Aspen Hysys, what we take as the fee is 170K for 3 weeks training. So for those persons that don't really have that financial strength, you can start with this smaller software. If you want to grow in the industry, you know that you want to work in the oil and gas, or you want to work in the engineering settings, you need this skill. So imagine you go to a doctor, and he tells you that he does not know how to prescribe a drug for you. You definitely run away. Or you enter the car, an Uber or Bolt, or you enter the taxi and you found out that the driver cannot drive, or he does not even have a driver's license, nothing. You definitely not want to continue that journey because the person is not fit. So this is one reason why most young graduates are not employed or are not employable. In fact, most graduates in Nigeria and some part of Africa, they are graduates, yes. Some of them might have first class, second class upper, second class lower. But you are not employable because what you have been taught in school does not match up what is required in the industry. And they say, okay, let's look for somewhere we can fit you. You don't even know any software at all. So you just came out of the university without nothing, only your certificate. And certificates don't give job. Skills, expertise, competence is what your employers are looking for. So for those of you that will participate in this 2 days program, I would like you to not miss any session. Due to the fact that we want to upskill a lot of graduates, we want to see a lot of graduates become employable. We are also going to run a paid session after this. And this paid session is going to be very affordable. We are going to run a 2 weeks training on Aspen Hysys, and it's going to be just for 15,000. Normally, I told you we do run training for 3 weeks, 170. But for this, and a lot of persons participating in this is from SPE. Yeah, a lot of you are from SPE. So we are going to be doing that for 50,000, and I will make that known in the group chat. So for those of you who are participating and you haven't subscribed to this channel, I would also like you to do so. Like and share this session for those who are yet to participate. to your friends and colleagues. Okay, so this is my Aspen Hysys screen. We are not going to, jump into Aspen Hysys. I just share that screen so that whoever is participating or joining the call will know that, yeah, we are live. So before we dive in and start doing simulation, this and that, I would like to go through the basics of Aspen Hysys so that you know where you are. You need to know what you need to know, because if you don't know what you need to know, you don't know anything. I don't know what I said. Anyways, I just said that to make the class fun. So I'm going to share my training slide now so that we start from the beginning part of Aspen Hysys so that everyone can be carried along. Both fresh graduates, new graduates, whichever category you find yourself, you'll be able to follow suit. Okay, just give me a minute. Okay, I believe you all can see my screen. The word Aspen, an acronym for Advanced System for Process Engineering. It is based on flow sheet simulation. So the word Aspen is actually an acronym, and that acronym stands for Advanced System for Process Engineering. And it's how it works is basically flow sheets. Now, what's the flow sheet? Because there are two key statements of words here which we need to put consideration or take into consideration. 1 and 2. Flow sheet. So as we go forward, some of you can give us these definitions in the chat box. What is a flow sheet and what is a simulation? What is a computer simulation? So by definition, a simulation is some resources will call it a pictorial diagram. Some information to say it is a way of representing an information through diagrams. Some information to say it is a diagrammatical process of representing how a problem is being solved from the beginning point up to the end. So whichever resource or resources you consult, material, the word diagram needs to be in that definition. So in chemical engineering or process engineering, a flow sheet is basically a diagram that shows how a raw material, the feed, moves from the inlet up to the outlet and all the stages involved. That's basically what a flow sheet is. And for those of you, I'm glad most of you that are here are in engineering, gas, petroleum, chemical engineering. You know that we have that some basic documents, way of representing information in a plant. We have our BFD. We have our PFD. So I would like someone to tell me the full meaning of this PFD. And we also have P and ID. So these three are diagrams that shows you, stages of a process. Now, I would love someone tell me the full meaning of BFD, that of PFD, not PDF rather, PFD, PFD, and P and ID. So I'll be waiting for that in the comment section. So while I'm waiting for your input, I want this class to be interactive. Now we are also going to look at a simulation. When you say simulation, what does simulation mean? So what does a simulation mean? A simulation is actually trying to carry out um, how basically trying to replicate how a system in reality is going to work in a virtual space. So I'm going to pick examples that are outside, engineering. For instance, you see, let's use road safety or car riding. We want to know the impact a car is going to have when it collides with another car, maybe running at 150 meters per hour. Now, we can't carry two people. We won't carry somebody like, let's use Francis. Yeah, Francis identify himself. We won't tell Francis, come and drive a Lamborghini and make sure that you are riding at 150 miles per hour or meters per hour. Let's miles per hour. And look for some other person called Francisca, put the both of them inside the car. Then they run for, at a speed of 150 miles per hour, then collide. We all know that these people are going to be injured, fatally injured, or even they may even die. So instead of putting people's life at risk, damaging car, we can simulate that scenario. Take all the parameters, friction, aerodynamics, the weight of the car, and every other thing. Use a mathematical model, which is basically the simulation. Those are mathematical models, and try to replicate how that car, the collision, the impact, the fatality rates, of the passengers or the driver or the subject. Now, that's basically what simulation is, and this is the process at which Spe Hysys carries out its operation. Now, if we put these two together, we can now say that Spe Hysys is based on operates based on a diagrammatical way of representing a chemical process plant from the start point up to the end, and carrying out this simulation, how carrying out this simulation in a way of representing a real plant operation. Now, when you do something like this, one of the key things we want to achieve, is to, one, save ourselves costs, because you can't build a plant, then you want to now start doing trial and error. So it saves you that time of trial and error. All the trial and error, you are going to carry it, they are going to do those stuff in your simulation. So from definition here, a flow sheet simulation is a computer software that is used to quantitatively model a chemical process plant, which in addition to the core reactor also include pre and post treatment steps. Okay, yeah, I said someone should tell me the definition of, okay, yeah, someone said P process flow diagram. Yeah, that's correct. Block flow diagram, piping and instrumentation. Yeah, you all are correct. Okay, thus simulation of an entire chemical process plant starting from the raw material up to the final product. So this is basically what we are doing. We are simulating the whole process from the start. This is this steps. So we have something like this. Basically, you all must have seen a PFD before. Get you have some of that in here, whatever this is going to represent. Then we have our output. Then this entire process from here up to this point is the processing. This is where processing comes in. Then you have here inputs. Yeah. So that's what we are saying here. Simulating an entire process starting from the raw material up to the finished product. And it is symbolically represented by icons. So if you have seen a PFD before, process flow diagram, it is being represented by icons. So those machines, your furnace, your processor, your separator rather, your heater, your heat exchanger, your cooler, your compressor, your pump, all those things are represented by an icon. This icon represents each unit or each equipment. Yeah, and where each icon stands for a unit operation, chemical process, input and output material stream. Now, in order for me to know that, or to be sure that you guys are following, what's the difference between a unit operation? We have a unit operation here and a chemical process, or a unit operation and a unit process. We can call this unit process. So what's the definition between the difference between a unit operation and a unit process? Spe Hysys is basically just one part of the entire system. You cannot model or simulate what you don't understand. Now, imagine if you had not gone through university and somebody is saying something like a feed. The feed, design basics. You won't understand those stuff. You can train anyone. You can train maybe an O level. Yes, this is the icon. If you want to add something, use this, click here, click here. But that does not mean that person is a chemical engineer. That does not also mean that person is a process simulation engineer. It's for you to know the core basics, the foundation, the integrities of chemical engineering, those theoretical aspects. So all these are necessary. And that's why I need to start from the basics to make sure that everyone is following. We all know what is input and output material stream, input and output energy stream. Clear all this. Okay. Now, why Spe Hysys? What does it enable us to do? One, it helps us conduct what-if tests. Now, this what-if test can be seen when you are doing your PSV, which is a process safety valve. You want to do your PSV sizing, that's for safety analysis. Now, you are going to carry out some scenarios like if there is over pressurization in our separator, what happens? What if there is fire incident? What if there is over pressurization? What if there is flooding? What if so you can use Spe Hysys to do that. Design specification. Our pump is operating at this requires this heat duty. Now we need to design this pump to know its operation curve and give it to the mechanical guys for them to do procurement. Also design specification, our distillation column, how many stages. So if we know the amount of stages we need to now do what? Design it. Or if we don't know the amount of stages, what amount of stage will give us this purity, this percentage purity? So all those stuff you have been learning in university wasn't for granted. So we also carry out the bottlenecking of constricting part of process. So when we are saying the bottlenecking, let's assume that a plant is supposed to give us maybe 10,000 barrels per day. 10,000 barrels per day of crude. Okay, now gives you 10,000 barrels per day of crude. Now, after building the plant, you now find out that that plant cannot give you that 10,000 barrels per day. Maybe it's giving you 8,000, 9,000. It means there is something isn't working well. Now, with Spe Hysys, you can now simulate that whole entire plant if you are given the necessary parameters to do that. Now, after you have done that, definitely uh, under operating conditions, you are supposed to simulate and get the same 8,000 that these people are getting. Now, with that, you can now carry the bottlenecking. You can now check in, okay, what can we modify? Do we need to add another separator? What exactly is not working well in this? So that's what is the bottlenecking. You're trying to understand, um, carry out some kind of sensitivity analysis. Okay, do we need to change the separator we are using? Is the demister not functioning well? Where are we getting this friction that is making our plant not give us this percentage of throughput or output? Now, I've also said something about sensitivity analysis, which goes with the bottlenecking. Then running optimization investigation also. So we can also design better plans and increase profitability. Now, imagine if previously you were, this train is giving us 8,000, and after we carried out the simulation, you know, carried out the bottlenecking, performed sensitivity analysis, and run optimization investigations, we are now able to get 10,000 watt barrels per day. First of all, we have designed a better plant. We have also increased our profitability of that existing plant. I believe um, I believe you all are understanding, you are following, right? Yeah, I would love to know if you are following. So if you are following, just let me know in the comment section. Okay, yeah, a lot of you are following. Okay, so as Spe Hysys process simulation, you can translate the simulation um, model, or you can carry out a simulation by doing the following. There are 5 steps in this. So the first step is to specify the component. And in order for you to do that, we have a Spe Hysys database. Specify the thermodynamic model to represent the physical properties of the components and mixtures in the process. This is the second step that needs to be taken. So to More explanation on thermodynamic model will take place in the paid class, which I talked about. So now this second step is very vital. We all know that if you are solving the wrong question, you cannot get the right answer. A Spe Hysys thermodynamic model um, is basically the center point, is the center of everything that you are doing in a Spe Hysys. If you pick the wrong thermodynamic model, every simulation you are going to carry out from beginning to the end is going to be wrong. So knowing the correct thermodynamic model saves you a lot. Now, when we are talking about thermodynamic, we are basically talking about the characteristics of that component: pressure, temperature, composition, and all of that. There are specific thermodynamic models for different components. If you are using an electrolyte, if you are using azeotrope, whatever you are using there, you know, in the oil and gas or engineering, there are standards to everything. So it's basically, if you want to do this, you follow this model, you follow this standard. We have the API standard. There are different types of API standard. Even while carrying out your simulation, your sizing, there is a standard for sizing a two-way separator, a horizontal two-way separator. There is a standard for sizing a vertical two-way separator. There is a standard for sizing a three-way separator. There's a standard for sizing a distillation column. There's a standard for sizing a pipeline if it is a gas, if the fluid there is gas, if the fluid there is liquid. So there are different standards involved in this. For those of you that, I don't know if you are already in the industry, I would like you to indicate in the comment section if you know what I'm saying is correct. And yeah, so that those persons that are fresh graduates will know that whatever we are saying here is not bluff. So there are standards to all this. For those of you for the oil and gas sector, there are specific thermodynamic models we use. And if you miss it, you have missed it. So like I said, we are going to go deeper into that and explain that fully in the main session that is coming up. Now, the next thing we need to do is to define the process flow sheet. We define the unit operation in the process. I said someone should tell me the difference between what is a unit operation and what is a unit process. I can't see any of that in the comment section. You can't see any of that in the comment section. So does it mean no one knows the difference between a unit operation and a unit process? Okay, so the first thing we need to do is to define the unit operations in the process. We need to define the process streams that flow in and out of the unit operation. We need to select the models from a Spe Hysys library. Now, when we say model, I'm still talking about the thermodynamic model. Library to describe each unit operation. Then the next thing, label each unit operation model. Okay. No. I think select a model from Spe Hysys model library. Now there are different models there, which when we get that, we are going to take a few examples, carry out real life simulation in our next class tomorrow. The next thing we need to do is to specify the component flow rate and thermodynamic condition Now, I said thermodynamic conditions has to do with the temperature, pressure, and composition of these streams. Then you specify the operating conditions for the unit's operations, like if you are using a splitter, you can now define the split fraction. What percentage of your feed goes to this point, or what percentage of the input goes to this point, what percentage goes to this point. And okay, let's go back. Okay, making a better use of the energy resources. So I believe, I don't know if I'm still live. Can you all see my screen? You all can see my screen, right? Okay. Just give me a minute. Let me share my screen. So the various applications that process simulation has found are results of necessity, making a better use of energy resources, minimizing the operating cost and the emission of waste streams that may be contaminants, increasing the yield and process efficiency. In terms of increasing yield and process efficiency, I explained that when I talked about this when um, I was talking about debottlenecking, process optimization, and all of that. So improving the process controllability propelling the teaching of process design. So one of these is, the class you are taking now. These are file extension types in Spe Hysys, which I'm not going to bore you with. So there are basically few steps in carrying out modeling. The first thing is set up, specify your units, specify the component, the property, the block, your streams, connection, then you run your simulation. Okay. Now let's switch to Spe Hysys. Let's switch to Spe Hysys. So before I continue, so far, are you enjoying this class? Is it flowing? Do you have any questions so far? Yeah, I need to take questions before moving further. Okay, no one has dropped any question. I'm waiting for question. Okay, someone asked, where can we get the software? Um, getting the software isn't going to be an issue for those that we go for the paid session after this. We'll make that available. We are going to make the software available for you guys. The only thing you need to do is that you should make sure that you have data to download it. Yeah. Does anyone have any other question? Okay. So you all can see my husband, my screen. Today we are going to have an introduction, basically an introductory session on the interface, how to select your components. Then tomorrow we'll be getting to deep into basic simulation with Spe Hysys. So I believe we are good to go. Now, this you might not see exactly this because, for instance, I have worked on previous models, so which is what you can see here. Yours is going to be empty because after installing simulations with Hysys, then from here you can open a new case, or you can create a new case. Rather, you can open existing file. So you can open existing and you can create new. And before we start creating new, there are a few other things I would love to show. If you click on customize, there are other things which you are not going to worry yourself on. I'm going to talk about resources. So for resources, we have what is new, we have examples, we have training model, events, announcements, all content, support, updates, live chats, and all of that. So for you that will be using the crack version, what is accessible to you is what is new, what's new. Examples also, yeah, is also available to you. When you click on example, they are examples as Spe Hysys already has inside inbuilt. We have acid gas cleaning, methanol partitioning, plant data, pressure relief, um, LNG simulation, LNG compression, heat exchanger level control, ethanol plant, whichever one you want, or you want to see how it was carried out, you can simply click on it. You have natural gas dehydration, you have nitrogen rejection using cryogenic distribution or distillation rather. So whichever one, if you want to design or simulate rather something similar to this and you want a clue, you can click on any of them. If what you are looking for is here, you have, so you also have crude oil fractionation facility. We can open this to see how it looks. Okay, we're going to give it a few minutes to load. So this is what we have. We have the preheated feed, and this is a two-way separator. You can see we have the furnace here. We also have a mixer here, which then goes into our distillation column. We have different um, we have different fractions. We have residue. We have diesel, kerosene, naphtha, wastewater, gas off, and all of that. So if you want to carry, you are looking for, an example, we have one. And this applies to um, every other example you can find there. This is basically how it looks like. You can open any of them. You can open any of them and take a look at how it is. So I'm going to close this case now. Okay, come back to resources. What is new? If you click on what's new, you are going to see I'm using V11, which is version 11, meaning there was version 10, there was version 9. So for V11, you can see the general improvement that was made on this software compared to V10. If you have the time, you can go through that. So for this exchange is accessible to only those that have the licensed version. So from here, you can access Aspen Tech production training videos. You can see simulation models. You can get updates about events that is being carried out by Aspen Hysys. You can also know about their product release, patches, announcements, and all of that. All their contents on Exchange can be found on all contents. So I'm clicking on File and click on New. Click on Case, New Case. Okay, so from here, this is our simulation window. We have different sections. We have property, we have simulation, we have safety and energy analysis. for now, we are in property. And this is where, if you recall from our slide, we said the first thing you need to do is to set up and set your unit description and all of that. So for that, you click on property, and then after you set your unit, the next thing is to set your components. So in order for us to set our components, we do that under the property tab. Now, when you click on property, which is where you'll be taking first, you're going to see your component list, and you're going to see your fluid package. The fluid package is basically this specific thermodynamic model that suits the characteristics of the components you want to use. You might not understand that now, but in the paid class, you are definitely going to understand that. Then for that, we click on, we are already in the property tab panel. We click on add. Okay. Now this is Spe Hysys components database. We have different components here. You can see methane, you can see ethane, you can see propane, iButane, N-butane, iPentane, N-pentane, N-hexane, and all of that. So all you just need to do is to select the component you want and click on add. Now you can see by my left, methane has moved from here. Methane is no longer here. You can't find methane here any longer. Same thing applies to ethane. Ethane has moved to my left. You can see it. Now, whatever is on your left is the component you have selected. Whatever on your right are components you have not selected that is ready for use. Now, this on my left is what I want to use. This is ready for use. This is what I want to use. So this is ready for use. Arrow F U, ready for use. Here, I want to use IW. So now you can see methane is what I want to use, ethane is what I want to use. So the fact that all these things are here does not mean you are using them. So I'm adding more components to my component list. After you have done that, the next thing I'm going to do is to select my fluid package. We are going to go deeper into this fluid package. And this is what I said, that if you add the wrong fluid package, you are going to get the wrong simulation results. So for this, I'm going to select Ben Robinson. Yeah, I'm done with the basic things I need to do in my property window is okay. Then I'm now going to move over to simulation. Simulation is where you now carry out the main flow sheets we have been talking about, where you use icons to represent equipment and icons also to represent the flow stream. So here we have our model palette, which houses the equipment, symbol of different equipment. And we also have our feed stream or material stream and our energy stream. Don't know if anyone have a question. Okay, there's no question so far. We have our material stream, we have our energy stream. Currently, we are on all. So you can see all equipment here, starting from mixer, splitter, heater, cooler, heat exchanger. We have pump, control valve, pressure relief valve, separator, three-phase separator, tank, compressor, expander, distillation column, and all of that. So there are a lot. You have your furnace here, you have your LNG exchanger, you have the plate exchanger, and all of that. So you can also see your plug flow reactor here, conversion reactor, equilibrium reactor, Gibbs reactor. So there are a lot of things you can carry out. There are a lot of simulation you can carry out with Spe Hysys, and we have most of those things here, you can also customize your own equipment, assuming Spe Hysys don't have the required equipment you are looking for. I believe you are good to go. Okay. So this is it. You click on the material stream, click on it and add here. Click on the equipment you want to include. I'm going to click on two material streams. Okay, so these are, we have 3 streams here and we have our mixer. All we need to do is to double click on the mixer, then add the streams. You have stream 1, we have stream 2, we also have our outlet here. You understand? So you can see we are not yet carrying a simulation. This is just basic demonstration. I'm going to back up a little bit. Okay, now there are different color codes here. We have the color code on blue, we have the color code on red. Now, when you are doing any simulation and you have this blue color, it means there are parameters that needs to be defined. Your equipment most times, equipment, the moment you add an equipment, it shows red. It means there are no strings attached to this. It's fully undefined. For your material stream, it shows this light blue, sky blue. Yeah. Then we also have on our bottom message section. It gives us warning, what we are supposed to do, what we are not supposed to do, what we have done. If there are errors, if there are warnings, we can see that in our message box. We can see that on our message box. Now, if I double click on this and start adding streams, okay, I'm going to add this stream. Then I add my second stream. I add the third one. You can see that the color has changed. Initially, it was red. Now it has changed to ash color with some with yellow lining outline. Now, what this means is that Spe Hysys is recognizing the fact that you have given it an input stream and an output stream. But what is telling you that there are this equipment has not yet been solved. Like this whole simulation has not been solved. Spe Hysys cannot accurately tell some of the parameters. It can't solve some of these parameters. Your mixer cannot solve. So that's basically what it's telling you. So whenever you see something like this, you just know that, okay, maybe you have not defined some parameters in the input stream. So the moment we add parameters, random parameters here, Spe Hysys automatically calculates and gives you whatever you want. So I'm just giving random. We are going to do all this tomorrow. So I just want to give some lies. Okay. So for this, you can see that we have this on thick blue, navy blue, and we have this light blue. Now, what is telling you that this stream you have given Spe Hysys all the parameters it needs. This stream has been fully calculated. But this other stream 2, the parameters we need are not there. And if you open it, you can see that we have not defined temperature, we have not defined pressure, molar flow, mass flow, none of that. We have not also defined the composition. We have methane, butane, propane, and with the mole fraction, nothing has been placed. But the moment we do that, you find out that this has changed to blue, and our mixer is no longer showing us that yellow lining or outline. Now, what this is a mixer, so it means Spe Hysys has um, has mixed these two streams to give us our outlet stream. So we are going to do all this in our class tomorrow. This is just basic introduction, and we don't want to overshoot so that everything is being understood um, clearly. So everything is being understood clearly. So I don't know if there is any question. This is where we are going to end today's class here. Then tomorrow we would take examples on this. So please, I would love to entertain questions. Do you have any question? This question has been asked before. How can you get the software? I said during the paid session, during the paid class, we'll make that available. Spe Hysys does not have free version. So we are trying to make the cracked version available, which is going to be available during the paid class. And information about that is going to be made available on the group chat. Okay, seems like today's class was well understood. No question. Okay, somebody's asking what's the difference between Aspen Hysys and Aspen Plus. Um, this is the key, the major difference. This is the major difference. Aspen Hysys is used majorly in the oil and gas. Aspen Plus, mostly is being used in pharmaceutical get and other areas. But in the oil and gas, what is being adopted and from research and previous finding, Aspen Hysys gives better results in terms of oil and gas simulation than Aspen Plus. But Aspen Plus solves more rigorous Aspen Plus solves more rigorous example than Aspen Hysys. So Aspen Plus is more advanced than Aspen Hysys. But in terms of the oil and gas sector, Aspen Hysys is more adopted and used. Okay, someone said, why did you choose Pen Robinson? That is going to be, I said that previously that I'm going to explain that in the paid class. Why Pen Robinson is being used. Then Franny IJs asked, please, to Aspen Hysys, you work with mathematical simulation model. Yes, as all simulation software use mathematical models, and they are complex and different. Each of those equipment there has its own specific mathematical model to run it. Emmanuel said, what if we don't have some parameters, like let's say a particular parameter isn't needed for what you are working on? Yeah, you will not specify all the parameters, definitely, but they are key. You can't be carrying out a simulation and you are not giving as analysis um, the temperature of your components. So how does analysis wants to know? There are basic things and important things you would give as analysis, like your pressure, the temperature, the flow rate, the composition. You must give as analysis your composition. Analysis won't automatically know the mole fraction of water in that mixture. You are going to tell analysis that, okay, this mixture is 50% um, kerosene, or 50% water, or 50% this, 50% ethanol, 50% methane, 0.2. Analysis can be used for wellhead and not all reservoir. There are specific softwares for reservoir. You can't do that with, but to some extent, there are some simulation you can do, some kind of wellhead simulation, especially gas gathering, something like gas gathering simulation. You can carry out that with Aspen Hysys. Okay. I'm still waiting for questions. I'm not sure what uh, their questions. I believe I've answered you all. Uh, we are going to see tomorrow, same time, 8:30 p.m. Then we would take examples, real life practical examples in tomorrow's class. Thank you all for participating in today's class. Have a good night rest. We are going to meet tomorrow. Thank you once again. Bye.